Hi guys, welcome back to the shop. Hey, I'm going to get back on the shift shaft for the Suzuki, and I've had a lot of it's been a pretty popular video so far. I'm really surprised. Machining stuff doesn't usually isn't really all that popular on my channel, but this one seems to be. So maybe there's some other folks looking for solutions out there too. I was kicking around with a couple of my viewers that comment pretty often, and I know Matt and Dean. Dean's got his own channel, Retro Mechanica. I was kind of thinking this yesterday when I was talking about the maybe hardening that spline area, and the more I got ideas from other people, I think what we're going to try to do, since 1018 it doesn't have a lot of carbon in it, so you can heat it and cool it until the cows come home, and it ain't going to do anything, just probably make it a little brittle. But there is a solution, and it's called case hardening. And you're actually just going to treat the portion of the metal that you want hardened. And you use a compound, you heat the metal, you use a compound to put it in while it's still hot, put it back in the oven, and heat it up again, and then take it out, and you can either cool it in oil or water or just let it cool, air cool. And by doing that, the metal actually absorbs the carbon from the powder that you use, and it will harden. It's a surface hardening. It's not going to harden the whole shaft, but it's going to harden just the spline area. That's what we really are looking for anyway. So I've done this in the past with a lot of different car parts, maybe a couple times with some motorcycle stuff, but I just had a passing thought of it yesterday when I was talking about this, and after reading some comments from Matt and Dean, I thought, yeah, I think this is probably what we need to do. So I've got everything we need to do, and this is the product that I use. It's called Cherry Red, and it's just a powder that it's got the carbon in it. So once you heat it, you wrap your part in it, and you just put this where you want it to be heat treated at. And the rest of the shaft should not be changed really much at all. So that's what we're going to do. I'm going to get you overhead here. We're going to discuss it a little bit. I've got my oven heating up already, and we're going to do this. All right, guys, before we discuss what we're doing, I've got the heater or the oven already warming up. Actually, it's hot. We're at 1375 degrees, and I've got 45 minutes on here. I'm hoping that's going to be enough. And I've got the shaft down here in on a little homemade tray here with in some stainless steel part wrap, and I'm going to put that in there while so it can go ahead and heat up. Hopefully we can get to what we need to. I may actually increase this to an hour. I think it's going to take a little longer than that, but I'm going to go ahead and get that in there. Let me get you on a tripod. Okay, we're going to go ahead and get this in there. All right, so that's warming up. Let's go talk about what we're going to do here. All right, this is the product that I use. It's called Cherry Red. It's an instant hardening compound. And basically all you do is heat the part and then coat the part and reheat it to cherry red again. And then you quench it in water, oil, or let cool, and then brush off the compound. It's a pretty simple process, and it's just kind of a powder. And evidently that's where the metal absorbs the carbon from this product. I don't really know how it works, but I just know it does work. Now, how are we going to figure out whether we've done any good with this process? I actually do have a couple ways. I've got this item here, which is a hardness tester. It's certainly not the most calibrated and reliable one, but it works pretty good. It's a PTC. It's an older product, but you can you just turn it on, you look through the lens, and it's kind of like a microscope, and see they have a test sample in here, and they've already put some marks on here so that they've tested it. And you can do the same thing and test it yourself, but you set this thing over the mark that you make with a spring-loaded punch, and the shape and the amount of spring pressure and all that tells it gives you the proper size, and it checks for the hardness of the metal. Otherwise a softer metal is going to have a bigger dent in it than harder stuff. So what I've done is I've gone over and I checked the piece that we just put in the oven, and I also checked this piece here. I really doubt that you can see them, but you might. I put a dimple right here and a dimple right there and checked them, and we're barely at 20 Rockwell. So this is very soft. They didn't anyway right here, I didn't check this end. Maybe I should. I've got to clean this end up, but I don't see any normally you would see some kind of a bluish or something down here where it's been hardened, and I'm not seeing that. And by the looks of what's happened here, this is soft. There's no doubt about it. Actually, I did hit it with a file right here. Anyhow, I've done that, and we're barely registering 20 on the Rockwell scale. And there's another way you can do it. I've used these. They're a file set. They come from Japan, and if you can get like this one here says Rockwell 40, and then we go all the way up to 65. And I guess the idea is that if you can scratch the product or the part, whatever you're working on, with that file, like this one does, then that is what it is. And you just keep going up until, if, in this case, we don't need to go up because we're already scratching it. That's a 40, and we're already figuring this is at a 20 or less. So if you've got a hardened item, you just keep going up until it actually grabs some and files it off. So that gives you a rough idea also. And these aren't very expensive, and they do work. There's some big, really gee whiz machines that do all this stuff, but I use this stuff so seldom. I was able to get this used. If I couldn't have got it used, I wouldn't have bought it. And these, I want to say I got them off of Amazon, and they might have been $75, but I'm thinking more like maybe 50. But anyhow, there's ways to tell. And like I said, after I spoke to a couple of the guys that commented on there about the hardening, I thought, you know, we need to try to do this. So that's what we're going to do. And I also had one person ask me why I didn't just make a whole new shaft. You could do it, but you've got to start from this size material in this case. Or you could possibly cut this off and try to get centered here, drill, and you know, I thought about it, and I just thought this is the easier way to ensure everything stays straight. You know, you would have to come in here and mill this. You start with a bigger piece of metal, cut a lot of metal off of it because we're going to be out here. And anyway, with me, when I'm cutting down long lengths, and this is, I consider a long length, I've got so much floor shift in my shop that it's hard to keep my lathe level. And I'm good to maybe 12 inches, but like yesterday when I was cutting the piece down that I was doing, I was almost a thousandths difference on this end versus the other end. It was close enough for what we're doing, but I actually went in with a file and took off the extra thousandths up here and kind of feathered it out until I got to the same here, and then sanded it down. So I went with the easier way. You know, I could have done it, but I think I probably would have spent another 3 or 4 hours doing it, and I would have wasted a lot more metal. So that's why I didn't do it. I did think about it, but you would have, like I say, you'd have to make this area here and get it clocked right and all that. So it's, I don't know, that's why I didn't do it. If this doesn't work out for some reason, then that may be my option. But I don't think we're going to have any trouble working this out. Okay, this is what I'm looking at inside the viewfinder here. I'm looking at this, and this is the dimple I just put into the metal with my calibrated punch. And what I do is you line the bottom of the dimple with the line down here, and then where the other dimple or the edge of the dimple shows, then that is how hard your metal is. It's pretty simple. I mean, it's simple to use. I'm sure it wasn't that simple to design and make. But if I was looking at this one right here through the viewfinder, I would know that it is 45 Rockwell. You line here and you line here. And if you're in between, well, you're just in between 40 and 45 or whatever it may be. But in this case, when I checked the old one and the new one that I just made, we're way down here. We're lower than 20, like 18 or 19. So it's very soft metal. So once we do this procedure, we should be able to determine by this where we're at and whether we've made any progress. Okay, this is what we use to wrap that in. It's a stainless steel tool wrap. It's actually made for this. And you just cut off what you need and form whatever you're going to form to hold the tool. And I believe I've already got that in the little tray that I've already put in there with the tool. So I shouldn't need to do that, but I just wanted to show you the product. And that's what it is, stainless steel tool wrap, heat treating foil. So that's just kind of part of the backstory. Okay, let's pull this thing out. I've got some of my stainless steel wrap here, and I only want to do the tip. So I've made kind of a reservoir down here. So we'll put the rod in here, and then I'll put the red hot onto, or cherry red on it, and bury it in there. We'll put a little in the bottom first. And then we'll put some more on top of it and try to close in just this end. And the extra rod will lay out here and it won't be part of it. Okay, we'll go ahead and turn that off. Pretty hot. So I'm just gonna dump it in there. Get my little tray out of there. Now I'm going to cover this up, and one thing I'm going to do is when I've got another piece, I'll go ahead and put over the top of it. And once I do that, I'll put one kitchen match in it. I'll just break the head off and stick it in there. And that, from what I understand, once this heats up again, it will light that match and it'll burn all the oxygen out of there. And that's what you want. You don't want any oxygen in there. So let me get this wrapped up. Okay, we've got it all wrapped up. Tried to get it as airproof as I could, and we're going to put it back in. And I've got it set for another hour. And again at 1375 degrees. That's what the manual is telling me, that's what it takes to make steel cherry red. And I just want to show you too that there's an app that I use on my phone. It's called Heat Treat. It's a free app you can get, and you can go through, you can find the alloy you're looking for, whatever you're looking for, and it'll tell you all the specifics of that material. Okay guys, we're down to a minute, and we're still right around 1375 degrees. I'll get you here. I'm going to go ahead and open the door, and you can just kind of see what everything looks like in there. And I'm going to go ahead and turn the heat off. So there's our part. There's the inside of the oven. So what I'm going to do is I'm going to elect to let it cool down naturally. So I've already shut it off, and it's starting. You can see the decline on the heat already. So it'll be a slow, you can do it any way you want to, but I've always had better luck personally letting it cool off naturally, unless you really need it hard. But with case hardening, you're not going to get it but just so hard. You're not going to get it hard through and through. It's only a surface hardening. So I'm going to do it this way. So probably in a couple hours, everything will be down close enough where I can open it up and take it out. And you just want it to kind of cool off slowly. So that's what I'm going to do. All right, we're down to 563 degrees and still dropping. It's been about a little over an hour, about an hour and 15 minutes. So we're still waiting. Okay, got it out here. It's still a little warm. Let's see if we can get it tore apart here. Most of that is just kind of chipping off. You got to resist the temptation of reaching in there and grabbing it. Okay, that's pretty much it. Now I'm going to have to get get some water and clean it up. Okay, it's still hissed a little bit. It's still about 400 degrees. Okay, this stuff's supposed to be water soluble, and you just have to kind of soak it and get a wire brush and kind of work at it a little bit. So that's what we'll do. We'll work on it a little while. Still working at it. All right, let's take a look here. Now I actually did try the this tool here, but I don't think it's going to give us a accurate measurement because this is surface hardness, not overall hardness. And what I've done is I've taken my files and you know, really from this kind of dark area, from right about here down, is all that we've done. And I can take this file here, this is the 40, and it doesn't even scratch it. It just comes right off. And then I go to the 45, same deal. It's not even scratching it. Then I go to the 50 and I can feel it. See, you even got a little, I'm not sure that's going to pick up or not. So my thought is that we're between 45 and 50 on the case hardening. But as far as the using the punch and the PTC tool, I don't think you can get an accurate reading on it for that. Now, in you know, to look at the other end here, see, all I did was put the coating down here. So if I go to here, see, it definitely, that's the 40. That's the lowest one I've got. I can probably even do that with a regular file. I've got a little one here. Oh yeah. Yeah, this is just a normal file. So nothing's happened down here to this. It's only this dark area out here. So I'm thinking this is probably going to do what we want it to do. Hopefully that it's penetrated enough into the splines to give us what we need as far as durability. Only time will tell. But as of right now, I think we had success on our case hardening, and how much it'll help, well, that's yet to be seen. But I really don't think that it would have even been necessary. You know, if those other splines lasted, 45, 50 years, I'm sure these are going to do the same. So there you have it, guys. I think we've done some good on this. It's really not any. We haven't made a huge difference, but I think we have made a difference, and but it's kind of hard to determine that with the equipment that I've got. But you can readily see and hear that the file just glances off of it. Now, it may not be very deep, and I'm sure it's not. I'm sure it's just a few thousandths deep, but that may be all we need. Case hardening they do to a lot of firearm products, maybe even the firearm frames and that sort of thing. I believe they case harden a lot of that stuff. I'm not sure, but usually you can see that because they've got the darkened color, and it's kind of got a different. It's not a blanket color of the same. It's kind of comes in waves, maybe something like that. But anyhow, I think we've done some good, and that's something that you may want to consider. I guess we could have went with some 4140 material, but I think I probably would have ended up having to get a carbide cutter to do it. I've cut a lot of 4140, and it's hard. It's hard to start with. I don't think you would need to harden it. It would be hard enough to resist this problem, I think, by itself. But usually when I've cut that, it really cuts hard with a single point tool, and especially with my small lathe. Bigger machines I don't think has a problem, but I think that in a situation where you're rolling your pattern or rolling your tooling, I just don't know whether high-speed steel would do it. It might. Anyhow, I think we've done some good. I just thought we'd go over that, and the next video I'll try to get it put together and get it welded up. But I just wanted to go through that. So hope people enjoy this, and we'll see you in the next video.